if you're new to programming, okay, or if you already learned programming and if you're finding difficult to develop programs on your own, or you have learned C programming from a long time, or you have learned programming, you're interested in development but still finding it difficult, and you don't want to get involved into this. If you have such kind of problems, then definitely what I recommend is you watch this video from starting till the end. Okay, once you listen to this video, then two things will definitely happen. One, you will say that programming is easy. Two, you will say that from now onwards I can start developing programs on my own. So these two things definitely are going to happen. Once you finish this course, then you will say that C language is very easy and I can develop any program you give. And finally, when we finish the entire course, after C, C++, whatever the things that we need to become a software developer, once we finish this, then you'll come back to me definitely and say that now I'm a developer, now I'm able to develop projects. So what we'll do is we'll start the class. C language, the first thing what we have to know is we have to see why we are actually learning C language. If somebody asks you the question that why you're learning C language, then what will be your answer? Why are you learning C language? You are learning C language because it's the basics of programming, right? Because it's the basics of programming, or you're learning C language so that you can become a C programmer, right? So if somebody asks you the same question, why you are learning this, then your answer shouldn't be that. You're not learning C language because it's the basics. You're not learning C language because you have to become a programmer. Then why actually you're learning C language? To understand that, what we'll do is we'll take an example. Let's say you have a servant, okay? You have to send him to a market and ask him to get potatoes and onions. The problem is your servant is deaf. Now you have to send that deaf servant to get potatoes and onions. Oh, what will you do? There are options, right? Okay, the one option what you can do is you can use the sign language. You can say like this, but what he will do is instead of getting potatoes or onions, he can get eggs, right? So it's an option, but it's not a good option. Other thing what you can do is you can go get a potato, show it to him and ask him to get it. He can get it, but what if the potatoes are not available? Then you cannot show him, right? As you said, the best thing to do is write it down. Okay, if I write it down, then definitely your servant will do that work. Let's say your servant knows English language, okay, and I'm writing it in Spanish. Will he do that work? No, he cannot do that work, right? Okay, now if you ask me who is this servant, who is a deaf person, right? Your servant who is a deaf person is nothing but your computer. If you see the computer, it can do any work, right? But can it listen? No. Okay, that means I can call your computer as a deaf person. Yeah. It can't hear anything, but if you look at it carefully, it does every work that you want. Now how does it do it? Definitely what you do is, okay, you write it down. Whenever you want the computer to do any work, you write it down. Once you write it down, then the computer does that work. Okay? But what language you know? English. So because I know English language, what I'll do is I'll write it down in English language and I'll give it to the computer. Will the computer do it? No. Because the computer doesn't know what? English. So what you have to do is you have to write it down, but in which language? No, you have to write it down in the language which the computer knows. So next time onwards, if you want the computer to do any work, what you will do is you will write it down, but write it down in which language? The language which the computer knows. And what language the computer knows is, it knows C language, it knows C++, it knows Java, it knows PHP, it knows a number of different languages. Okay, so what we'll do is, whatever C language you will take, and once you write it down in C language, let's say, because the computer understands, so what it will do is it will do your work. Now you tell me what you have to learn.
C language.
You have to learn what?
C language.
C language. Because once you learn C language, you will have the skill to make the computer do whatever you want to do. So next time onwards, if somebody asks you, let the computer add two numbers, will the computer add two numbers? No. But because you know C language, and that's what we are going to learn. We are going to learn C language, so that once we learn this C language, then what we have the skill is, now the computer will do whatever you want to do. That is why you're learning C language. Now, is this class, I have explained it, what, 5 minutes? Okay, is this important or not in context, right? If we look at that point of view, this 5 minutes is important for the entire C course. In every concept that you're learning in C language, if you forget this 5 minutes, forget about C language, forget about becoming a programmer. It is that important. Now, if you have any doubts like that, just let us complete this entire class once. Once this class is completed, then you will automatically understand how important this question is. So again, I'm asking you, do you know why you are learning C language or not?
Yes.
You're learning C language. Why? Because you want, once you learn that C language, the computer will do your work, however you want it to work. Are we clear with this?
Yes.
So we are clear. So once we are clear with this, we'll go to the next step, next concept. So from 5 minutes, I'm repeating this. I have repeated it 5 to 6 times, 7 times. Why you're learning? Because we have to make the computer work, whatever work we want the computer to do, right? That's why we are learning C language. The next question comes, how does the computer work? Right? Because you learning this because you have to make the computer do some work. But if you don't know how the computer works, then we cannot do anything. So the next question what we'll learn is how the computer works. Okay, if somebody asks you this question, very easy answer, right? How the computer works. It exactly works like a human being. The computer exactly works like what? Human being. What actually they did is, they wanted to invent something very good, something amazing. They researched and researched and researched, and finally they came to a conclusion that they can never invent anything better than a human being. So what they did is, they created a computer exactly like what? Like a human being. There is no difference between a human being and a computer. So again we'll come to the same question. How does the computer work? How does the computer work?
Like a human being.
Exactly like a human being. A computer works exactly like a human being. The next question comes, how does a human being work? Very easy. Okay, what are you doing right now?
Listening.
You're listening, right? Are you listening or not?
Yes.
Yes. So you're doing what? You're listening. Okay, what does a computer do? It will listen. Whatever information I'm giving, what you're doing is, you're listening to that information. Once you're listening to that information, you're taking that information, okay, and you're putting it into your head, or we can call it as a brain. Once you're putting that into your brain, then you're thinking about it. And once you're thinking about it, what you're doing? You're shaking your head, right? Okay, so this is what you're doing. How does a human being work? Every time, whenever a human being has to do anything, these are the 4 things it will do. It will listen. Obviously, we are listening from here. Then we are putting it into our brain. That means we are storing it into our brain. Once we are storing it into our brain, then we are thinking about it. And once we are thinking about it, then we are giving some kind of response. Now, if somebody asks you how a computer works, it exactly works like a human being. What does a computer do? It will first listen. Listen in the sense, whatever information you give, it will take that information. The second step, what it will do is, it will store. Okay, so what they did is, whenever the computer has to listen, okay, what they did is, they created some, let us say, they created a keyboard. So the computer can listen through what? Through the keyboard. It can take information through the keyboard. Once it takes to the information through the keyboard, what it does is, it takes this information and as a human being, right, it stores. It keeps it where? It keeps it in the memory. Okay, so definitely the data, whatever information is given, it has to go into what? Into the memory. Now once the data is in the memory, then what it does is it thinks about it. Okay, right? And once it thinks about it, but this is an English terminology. In a computer terminology, what they have given is thinking is nothing but what? Processing. So it processes it. And once it processes it, then that information it again gives back. Okay, that means what we can say is it gives back means it outputs it. This is a computer terminology. It outputs it. Where it outputs it, they have given a facility which is the monitor. So it outputs at what place? In the monitor. Clear? Now if somebody now asks you, how does a computer work? A computer works exactly like what? Human being. Right? And how does a human being work? Whenever a human being has to do any work, or whenever a computer has to do any work, first it has to take the data. Right? Second, what it has to do is it has to take the data and put into memory. Once it puts into memory, then it has to process it. And once it processes, then only it can give the output or the result that we want. Let's say I've removed this memory. Will a human being work? No. A human being will be called as what? A madman. Right?
Yes.
Because if memory is not there, a human being cannot store anything. Right? And if he cannot store anything, he cannot process it. And if he cannot process it, he cannot give any output. That's why people term them as a mad person. You have looked at mad person, right? You tell him anything, he just talks this and that nonsense. He never does your work because he doesn't understand anything. Why doesn't he understand? Because he has lost the capacity to store. Anything he's listening, but he's not able to do what? Store anything. Because he's not able to store, he's not able to process. So if the computer has to do any work, then definitely what should be there? Memory has to be there. And whatever data that comes from here, it has to be stored where? In memory. Are we clear with this? So we have learned two things, right? One, why you're learning C language, we know, because the computer has to work, as we say. Two, how does the computer work? The computer works like a human being, right? And it works like this. Surprise for you guys is, you have learned how to write programming. Amazing. Right? From now onwards, what you can do is, you can write programming in C language, obviously. We'll write programming in all the languages. Don't worry about it. But you have now the skill to write programming just by looking at this. This much important is this point here. It is that important. Once you get this into your head, and remember, in each and every concept, I'm going to ask you this. If you forget this, forget C language, forget programming or becoming a programmer. You have to remember this if you want to write programs on your own. Right? And we want to write programs on our own. We don't want to copy the program from Google, type it into our system, look at the output and be happy, oh, I've written a program. No, that's not how we write programs. Clear? So in this 10 minutes class, if you see, we have learned only 2 points. But these are the major 2 points in writing programs in C language. So what we'll do is we'll next move to the third concept. So these 2 concepts are clear. Now the third concept is, in all this point what we are saying is, data is given from the keyboard. If we have ever looked at a computer, we know how to give data through the keyboard. Right? The next thing is, it is being stored where?
Memory.
In the memory. Okay? So what we'll do is we'll expand this memory a little bit. Let's talk about memory then. Okay? So a memory, what they say is, if you want to learn completely about memory, you can visit my computer basics class where I will explain you completely about memory. Here what I am trying to do is I am trying to explain memory from a programmer's point of view. So from a programmer's point of view, a memory is divided into a number of blocks. Okay? So this is the memory. Okay? Now, this, whatever data is given, and the data is given from what?
Keyboard.
Keyboard. So whatever data is given from the keyboard must be stored in what?
Memory.
In memory. The next question what we have to learn is, okay sir, the data is getting stored here, but what is this data that we can give from the keyboard? Okay, right? So the data that can be given from the keyboard we have already seen. The data can be called as numbers. Can we say numbers can be given?
Yes.
Okay, 1, 2, 3, 4, 5, 6 or whatever numbers can be given. Clear? Negative numbers can be given, which we can call it as integers. Okay, so integers can be given to what?
Memory.
To the computer, and that has to be stored in what?
Memory.
Memory. So this is, let's say, numbers 0, 1, 2, 3. I can say like this. This I can take negative, -1, -2, 1, 2. Or the data can be given as real numbers. Okay, real numbers are nothing but values that have decimals. 1.2, 3.5, all this data we can give. Or we can give characters A, B, C, D. So what I can say is, I can give all this data from the keyboard, and that data will be stored in what?
Memory.
Memory. So I'm asking you guys, numbers can you identify or not? Yes. Integers? Yes. Real numbers? Characters. It's very clear. There is no doubt about it. So what I'll do is, I'll take an integer value and I'll give it to the computer. And it has to be stored in what?
Memory.
Memory. But does the computer know that it is an integer? No. Does the computer know it's a real number? No. If the computer doesn't know that it is a real number, how it will store it into memory? It can't, right? So from next time onwards, remember, whenever data is given from the keyboard and that data is being stored in what?
Memory.
In memory, okay, it is your job, right? Your job to tell the computer what type of data this is. If you don't tell the computer what type of data this is, right, the computer will never understand and it will never do whatever you want it to do. So whose responsibility it is?
Our response.
Your responsibility. Okay, who's giving this data?
We are.
You are not giving the data.
It's the user.
Remember, you people are not giving the data. Then who's giving the data? The data will be given by a user. Who will give the data?
User.
User. There is a big difference between a user, right, and a programmer. Now who's going to tell the computer that this is an integer? The guy who tells the computer that this is an integer is the guy called as what? The
Program.
programmer. It is the programmer's responsibility to tell the computer. It's not the responsibility of what? User. Are we clear? So the programmer, what he will do is, from next time onwards, your responsibility is whatever value that is given from the keyboard, you have to inform to the computer what type of value it is. Clear? But we are learning which language? C language. So we have to inform in which language? C language. If I just say in English language or mathematical language form, I'll say integers, the computer will not understand. We have to explain it in what? C language. So in C language, what they did is, if you want to inform the computer, okay, that from the keyboard the user is going to give integers, then what they did is, they have given something which is called as int. So from next time onwards, if I ask you to give int, what will you say? What am I trying to do?
From the computer that we are going to give integers.
From the keyboard. So we are trying to do what we are trying to do is inform the computer. Okay, right? Remember, you shouldn't give int directly. If you are giving int, you have to know why you are giving int. Clear? You are giving int so that you are trying to inform the computer that the user is going to give values in what? Integers. The computer will instantly understand, okay, this guy is talking about integers. From the keyboard, now I'm going to receive what? Integers. Let's say we have to inform about real numbers. Then in C language, what they did is, they have given something which is called as float. Once you give it as float, then you're telling the computer that the user is going to give what? Real numbers. Similarly, in C language, they have given what? Char. Remember, there is a difference. This is in C language. This is normal language and we are learning C language. So we have learned one concept. From now onwards we are clear that whatever value you are giving from the keyboard, it has to be informed to what? The computer. We have to inform the computer that it is what type of data. Clear? What type of data it is, whether it's a real number. In order to inform, the new thing that you have learned in C language is you can give what? Int. Okay, you can give what? Float. Or you can give what? Character. Based on what the value, whatever value the user is giving. So are we clear with this? Now this concept in C language is called as data type. It is called as what?
Data.
Data types. So in book definition, whenever you look at a C book or some book, they'll give the definition. They'll ask you what is a data type. Are we interested in that book definition? No. You are not at all interested in the book definition. You don't want to remember that book definition. What you want to remember is, if somebody is talking about data type, then what he is saying is, whenever data is given from the keyboard, and that data has to be put in the memory, before putting it into the memory, you people as a programmer have to inform the computer what type of data it is. Clear? It is your responsibility. Now I hope you will remember this in the next concept. You will remember it because I will ask you. And if you forget, and many students forget about it, don't worry about it, come back to this. Okay, listen to it again. If you forget about it, come back, listen to it 100 times also. If you forget and you'll come back and listen to it, there is no problem in it. So now what you are able to do is, let's say this guy has given 10. What you will do?
Int.
Because it's an integer and you have to inform to the computer, you will give what? You will give int. Once we give int, the computer now knows that you are talking about integers. Okay, the next concept is this value has to be stored where? In the memory. Right? And where we will store that in the memory? Here, here, here. Where we can store it?
Anywhere.
How does the computer know where to store that value? Right? The computer will never know. So I'll just give an option. Let's see whether that option is good or not. What I will do is, for this 10 value, okay, I will allocate a location like this and I'll give some name. Okay, any name. Let's say I'll give something alphabetical, let us say I'll give ABC. Okay, now if I ask you, okay, this guy is given, the user has given 10 value. Now I have to put it into memory. Okay, can you tell the computer where to put that value or not? Where?
ABC.
ABC. So from next time onwards, if any value is given from the keyboard and it has to be stored in the memory, the first thing what you have to do is, you have to allocate the memory, okay, and give a name to it. Once you give a name to it, then what will happen is, a memory will be allocated, then the computer will know where to store it. So the computer now can identify where to store that value or not. But it has to be done in which language? C language. It cannot be done in English language, but we have to use C language. So in C language, what they did is, they created a concept. Okay, they created a concept which is called as variable. It's called as what? Variable. Okay, right? Now if I ask you, what is this variable? Okay, a variable, why you are using a variable, or why I have actually talked about variable, you have to go back 5 minutes and you have to start from the beginning of this concept, that you tried to give a value, the computer didn't know where to put that value. So what you did is, you allocated memory. Okay, once you allocated memory, now the computer can identify where to put that value. That is why you are using what? A variable. A variable is that which will allocate memory, and based on that allocated memory, the computer will identify where to put that value. Are we clear with this?
Yes.
So we are clear with the fourth concept also. That is variable. They have given some rules for variable in C language. Okay, because they are giving a name. People can come, sir, what kind of name I should give? Right? Can I give anything? So what they did is to remove this confusion. Okay, they have put some rules, obviously. Right? The rules are very straightforward. It's like textbook only, definition only. What they said is, okay, in a variable name, they said that you can use alphabets, ABCD, variable name. They said that they can use numbers, 0, 1, 2, 3. So these things they said they can use. That means, can I use some, if I want to allocate memory, can I use ZA 1, 2, 3 or not? Yes, I can, because they have given that rule. Okay, but the second rule they have added that the first letter must always be an alphabet. Okay, so if I try to allocate memory by giving 1, 2, A, B, C, then it is wrong. I cannot do that because the second rule is the first letter must be an alphabet. Then what they did is they said that in a variable don't use special characters. Now special characters are nothing but plus, minus, divide, into. You don't use all these things. In the keyboard you can see all these characters. Don't use anything. Use alphabets or numbers. Okay, right? First letter must be an alphabet and don't use any special characters. If you want to use any special characters, then they have given only one special character, which is an underscore. Clear? So now you can use what? An underscore. For example, I can give A underscore B. Clear? Now if you look at in the textbook, these rules are given, so don't worry about it. But the main thing what you have to remember is why actually you are using a variable. Now do you remember that or not? I don't care about these things because we can look at it in the textbook and you can find it. But next time onwards, if from my mouth, if I say variable, then from your mind, the thing should come is, sir, I have to allocate memory. I have to give a name to it so that the computer will identify where to put that value. This thing has to come from your mouth. This is the concept that you have to remember. So we have learned 4 concepts up till this point. The first concept is why actually you are learning C language. Because from next time onwards I got to make the computer do whatever I want. Okay, so it will do my work. But how does it work? Like a human being. Don't forget. Like what? Human being. So if that question comes, you look at a human being, it works like this guy. Okay, what does it do? It listens. It puts it into memory. What if it doesn't put it in the memory? It cannot do any work. So it puts it to the memory, it processes it, and then it gives the output. Whatever way it gives the output, it gives the output. That's how it works. Then we came that data is given, but the computer don't know what type of data it is. So whenever a data is given, you will definitely have to tell the computer what type of data. So in C language they have given the concept data type. Right? So we'll write the data type, int, float or char, whatever based on the user. We have also learned the difference between what?
User
and a programmer. User is the guy who is going to give data, is going to look at the output. But a programmer is the guy who is going to instruct what? The computer. He is the person who is going to tell everything to the computer. He is the guy who is going to write down in the language of the computer. The computer will listen to the user or the programmer? To the programmer. It will never listen to the user. It will always listen to the programmer. Because he is going to give instructions. To give that instructions, one instruction we have already learned. Once we have given that, the computer now understands, okay, this guy is talking about integer. But second, we faced the problem that we weren't able to store the value. Then what we did, we introduced variable. Okay, and once we introduced variable, now the computer is comfortable. Has the computer put the value into it? No. It hasn't put the value into it. But at least what you have done is you have allocated memory, given a name, and now the computer can identify that I can put the value. Clear? Now based on this concept, what we'll do is we'll now try to make the computer do some work. Okay, right? So we'll start that process. Let's make the computer do some work. Okay, so in order to do that, we'll keep this, we'll keep the user, we'll keep the programmer, we'll keep the memory. Okay. So let's keep the memory here, and we have to display it somewhere. So we'll display it in the monitor. Obviously somebody must be there to process it. So let's take a processor which is going to process. So these are the 4 components that are there. Okay, one is monitor, where we can give the result, memory, keyboard, and the processor. This is how the computer works. Okay, so the first task what we'll do is we'll give the computer, okay, to add 2 numbers. So the user now wants to add 2 numbers. Okay, so we'll start. We'll see that how the computer will do that work, and how it will give the result. Clear? But as a programmer, if the computer has to add 2 numbers, the first and most important thing is, as a programmer, you have to know how to add two numbers. Okay, if you don't know how to add 2 numbers, can you write this program?
No.
No. Yes, we can write this program. If you don't know to add 2 numbers, you can write this program. How? You will hire an expert. You will hire an expert, ask him how to add 2 numbers. You will understand how to add 2 numbers. Right? And once you understand it, then you can write this program. Remember, don't say you cannot write programming, because we don't know everything. Nobody in the world, knows everything. Right? Because we have different specializations. So don't expect that you are going to write each and every program, or you are going to understand each and every concept. But you have to write it. It means you have to hire an expert or somebody, talk to somebody who has knowledge about it, know about it, and then we can write the program. So obviously this is a very small thing. And remember, am I teaching you how to add 2 numbers? No. I'm teaching you, how to write a program on your own. That's what we are teaching. That means if you learn this concept once, you can write thousands of programs without any problem. Easily. Right? You don't have to look at any book or anything. Automatically you can write it down. That's what we're going to try and learn step by step. Okay? Right? So we'll start. The first thing what we have to do now is, the computer has to add what? 2 numbers. And I know how to add 2 numbers. Okay? Simply in mathematics we have already learned. This is the maths form, right? To add 2 numbers is, I'll take 2 numbers, let's say 10 plus 20, and the result is what? 30. This is how we add 2 numbers. Larger numbers, smaller numbers, or whatever numbers, but this is how we'll add 2 numbers. That we know. Now the process is this same thing. What we have to do is, we have to see that the computer does this. Okay, so in order for the computer to do this work, obviously we have to give which value? 10 value to the computer, and we have to give 20 value to the computer. Once we give these 2 values to the computer, then it can process, edit. Clear? Okay, but already we have learned that if you're going to give 10 value to the computer, will it understand? No. But can we tell the computer to, in C language, can we inform the computer or not? Yes. How?
Int.
We'll give what?
Int.
We'll give int. So in C language we have learned already that technique to inform to the computer that the user is going to give an integer value. Right? So what I'll do is, I'll give int. Once I give int, now you're telling the computer that the first value that is given will be in what? Integer. So we have informed the computer. Now the computer is comfortable. But that 10 value has to we put in what? Memory. Okay. Can we put it directly? No. But we have to allocate what? Memory. Before putting that value, I have to allocate memory. And in order to allocate memory, we have learned a concept called as variable. And I can give any variable name. So what I'll do is, I'll give a variable name, let us say A. So I'm expecting whatever value the user is giving, I'm expecting that value to be put in what? A. Clear? Okay. So in order to do so, we'll give what? A. But that A must be what? An integer. So what I'll do is I'll give int A. So in C language, once I have written int A, then automatically now the computer, what it will do is, it will allocate memory with the name of A, and it is expecting which values?
Integers.
Integer values. So now I've allocated the memory for A. Clear? Now can I allocate memory for 20 or not?
Yes.
Okay, so in order to do so, again I have to inform the computer. Clear? Okay, so what I'll do is, let us say int, and I have to inform the computer that I have to put, so I have to allocate another memory, and let me call it as what? B. Shall I use A, B, or can I use anything?
Anything.
So we can use anything, so I've allocated B. So I've given what? Int B. Right? Now once you see this, and if somebody asks you why you are giving this, can you explain them or not?
Yes.
Right? In programming, that is very important. Even if you put a dot in programming, you have to explain why you have put this dot. You have to know why you are doing this. Otherwise, we are not going to write any programs. Okay? So this is clear. Once I give int A, memory is allocated for A. Once I give int B, memory is allocated for B. So int A, memory is allocated. Now once int A memory is allocated by the computer, okay, is there anything else to do here for the computer? Anything else? Or is there anything else the computer has to do here?
Store the value in the memory.
That's the next concept. Okay, so from next time onwards in C language, whenever you feel that this work is done, wherever that word comes, okay, this is done. This is done, right? Memory is allocated. This is done, right? Memory is allocated. Memory is allocated for A and memory is allocated for B. Now I can store two values. Okay, once in your mind that things come, so that thing you have to inform to what?
Computer.
To the computer that this work is done. In order to inform to the computer that this is done, you go to the next thing, right? What they have done is in C language, they have given something semicolon. So next time onwards, if I put a semicolon, what do I mean? Why I have given this
The
semicolon?
work is done.
Okay, in your mind that work is done. Once the computer sees that a semicolon is given, it thinks that okay, this is done. This instruction is done for me. I have to allocate memory. It has allocated it. It moves to the next line. Now once int B is given, what I have to do?
Semicolon.
I have to give a what? Semicolon. Now from next time onwards, you give a semicolon because I am telling you to give, or you will give it on your own.
We'll give it on our own.
You have to give it on your own. Don't do anything because I am telling you to do. Okay, you are doing everything because the computer needs it. You're talking to the computer, you're instructing the computer, do this, do this, do this. Int, it's an integer. You're talking to the computer. A, allocate that memory there. Semicolon, this work is done. So we are talking to the computer. Clear? So whatever next concepts I teach, don't do it just because sir has said to do it. Okay, we do it because it has to be done there. Otherwise the computer will not do your work. Clear? So up till this part, we are very much clear. Okay, this is done. Very good. Now once this is done, now the next job is to take this 10 value when the user gives it and put it into what?
Memory.
A. Okay, that we have to learn. So in C language, what they did is, whenever a value is given from the keyboard, okay, and it has to be put into a memory, they have created a function. Okay, a function which is called as Scanf. What function? Scanf. In C language course, we have a concept called as functions. There we'll learn completely about functions. Don't worry about it. Okay, what is functions, how we can create it, everything in detail we'll learn. That's not a problem. Here I'm using scanf function. Here the concept is why actually I'm using scanf function. Why I have to write scanf is the next thing that we have to learn. Right? If somebody asks you why you have written this scanf, it's very clear. You'll tell him that right? Scanf function will take a value from what? From the keyboard, okay, and put that value into memory. That is the job of scanf. Will scanf do this automatically? No. Scanf can't do it automatically. You programmer have to tell scanf, take that value and put it where in memory. It's our job. But what is the job of scanf?
To take the value and put it in memory.
It takes the value from the keyboard and puts it into what? Memory. Where it has to put it, it is our job. So C language, what they did is, they gave a structure for this. Right? So what we'll do is, we'll write the structure. Left parenthesis, you'll give double quotes, then you'll give a comma, right parenthesis. This is the structure of what? Scanf. Okay, so once we have understood this job, next what we have to do is, we have to take this 10 value and put it into what? A. We know that. And if you know computer memory basics, right? In computer memory basics, you learn that every block has an address. And that address is unique. Right? Every block. So what we can do is, we can tell scanf to put the value where? In what? In A. Okay, but here you have to specify the address. So in order to specify that address, in C language what they have done is, they have given something, an ampersand. Okay, but here is this an ampersand or an address? Address of what? The variable A. Okay, that means now you are telling is, boom, scanf, take the value from this keyboard, whatever value it is given by the user, okay, take it and put it into what? A variable at its address. Once I have given this, scanf will automatically take that value and put it into what? Memory. Clear? Okay, but this is user. Okay, and what happens is, the keyboard is in the hands of what? The user. Now because the keyboard is in the hands of the user, what he did is, smartly, he typed A, or he typed 1.2, he typed 1.3. He can give anything, right? Because the keyboard is in his hands. We have given it as integer. But because it's in his hands, right, what he will do is, he will give any value. And if he gives any value, scanf, what it will do? It will take that value and it will store there. But the computer knows that you are talking about what? Integer. Now that's a problem. Okay, so before putting any value into this memory, so that your program doesn't go here and there, what you have to do is, take that value and before putting it to the memory, you have to check what type of value it is. Okay, what format it is in. Is it integer? Is it? We have to check it. Once we check it, and then we'll put it into what? Memory. So who's going to check it? You or the computer? The computer is going to check it, but you have to tell what to check. In order to do so, what they did is, in C language, they have given something which is called as format specifiers. In the name itself they have given. Specify what? The format. That means check the format before putting it in what? Memory. That is being instructed to the computer. Okay, if it is an integer that you are talking about, we are talking about integer, the format specifier that they have given is %d. Okay, once you have given %d, now scanf, it will take that value. Will it directly put it into memory? No. What it will do is, it will first check what format you have given. If the format you have given and the value that is given is correct, then only it will store. Otherwise, it will take that value and throw it into the garbage. Who's going to do that? The computer. Are we clear? So from next time onwards, if I'm asking you people to take a value from the keyboard and put it into memory, what are you going to use?
Scanf.
You're going to use what? Scanf. Because scanf is going to do that. Are we directly going to put it, or we have to give the variable name?
You have to give the variable.
Variable name along with what?
Address.
Because each block has what? An address. So to specify that, we have given the address. Okay, is it good enough to just give the address, or we have to specify the format also?
You have to specify the
Format, because who has to check? The computer has to check what type of value is given. So what I'll do is, I'll give in these brackets, I'll give what? %d. Now we'll see how Scanf works. Okay, right? So before doing that, in C language, they have given format specifiers, %f. For char, they have given format specifiers, %c. As we go along, we can learn more format specifiers, as the data keeps on changing or whatever it is. But for the time being, we have learned this format specifiers. Now the question is, why you are giving format specifiers? Right? You got to answer that. I'm not just giving format specifiers. I'm giving format specifiers so that the computer can check what type of value you are giving before putting it into memory. It has to check that. Once it checks it, okay, this value is correct, then it will put there. Otherwise, it doesn't want unnecessary errors. If it tries to put a value directly, then there will be errors, memory errors, these kind of errors will come. And we want to avoid that in the computer. So to avoid it, simply we are giving a format specifier which will check this. So we are clear with format specifier. So what we have learned till now is, we have learned how to allocate memory. We have learned how to tell the computer what type of data it is given. And also we have learned to take this value and put it into what?
Memory.
Into memory. By using Scanf. Now you tell me, can you put this 20 value in this memory or not?
Yes.
Okay, so let's try. Let's try and do it. So first we'll write what?
Scanf.
Scanf. Then
Left bracket.
write down the structure. Okay, then we'll see where we have to take this value. Where? B. So we'll give B. Okay, and then we have to specify the address. So we'll give what? Address. Then we'll check B is what? Integer. So we have to inform that this format is integer. To do that, we have to give the format specifier. So we'll give it format specifier. %d. Okay. Once we do that, the computer now takes the next value. First, it will take the first value. Whatever first value is given. Let's say is given 50. It will take the 50 value. It will come here. It will catch that 50 value, compare it with %d. Integer, and in its hand, integer. Very good. Then it comes here. It sees where it has to store A. Okay, what is its address? It takes a value and puts it there. Similarly for B value. It takes the value, next value. It compares it here. Checks the format. Okay, everything is good. Puts it here. So another value comes here. Okay, is this work done?
Yes.
Have you informed that to the computer?
No.
We have to inform it or not?
Yes.
Yes. So, to inform it?
Semicolon.
Okay, if you will not inform, the computer will think that still work is there and it will wait. Oh, it's going, I have to still see whether other works are there or not. Okay, once it is done, it's done. So can I remove this?
No.
Because once you remove it, then it has to wait and see whether what I have to do next or anything is there. So I have to put it. So your program will not work. Okay, so up to this part, it's done. Right? So what we have done is, we have taken the value and put it into memory. Now the only thing what we have to do is, we have to add these two things. But we have to add them in which language?
C language.
C language. Okay, this is not C language. This is a mathematical formula. Okay, but because this mathematical formula plus is so famous, what they did is in C language, they didn't change it. But this is not going to last, okay? Only for plus, minus, multiplication, only for these things they have kept it similar. Okay, only for plus or minus I can say that. Right? They have changed everything else. So for plus, what they did is they haven't changed it. They have called it as an arithmetic operator. In C language, they call it as what?
Arithmetic operator.
An arithmetic operator. So in C language, an arithmetic operator, plus, minus, this is divide. Actually divide is, we normally write it like this, multiplication, an asterisk symbol. So all these operators are what? Arithmetic operators. Okay? We write it like this, multiplication. So these are the C language arithmetic operators. Clear? Now we have to add which value? A value, and then add which value? B value. So in order to add, I can use which arithmetic operator? Plus, which is C language arithmetic operator. Remember, this is different from this. That is an instruction to the computer to add the values which are there in the memory. Okay? So what I'll do is next step, because I have to add, I'll give it as what? A plus B. Now once the two values are added, again they have to put it, we have to put that result in where?
Memory.
In the memory only. Okay? Right? So the computer has added these two values. Now it has to be put where? In memory. But where?
We need to allocate.
We don't know. Right? Because we have added everything, this is good. But next thing what we haven't done is, we don't know where, because the computer will not know, not we, but the computer doesn't know where to store that value. So it is our job to inform the computer to store that value here. Okay, but to inform that, to store that value there, we have to allocate what?
Memory.
Some memory. So what I'll do is I'll allocate memory. Okay, and we know that if in order to allocate memory, first we have to tell what type of data it is. Right? So I have to inform what type of data it is. Clear? Let's say we are talking about what? Integers. So what I'll do is I'll give what? Integer. Then I have to allocate that memory. So I'll give what? C. So now C has been allocated. Okay? The work is done. I have given a semicolon. Now once the two values have been added, the value has to be put in what?
C.
Now in order to put that value in C, what they have done is, they have given something which is called as an assignment operator. They have given what?
Assignment operator.
Okay, in mathematics, you guys have seen this, equal. But in C language, it is called as what? Assignment operator. And remember, equal to and this one are same?
No.
No. They're completely different. In C language, this is completely different. Because in C language, what does assignment operator do? It does something similar to Scanf. Now, you tell me, what does Scanf do?
It
Takes the value
from the keyboard and stores it into the
Memory. It takes the value from the keyboard and stores it into the memory. Now, what does assignment operator do? An assignment operator takes the value and stores it into memory. The only difference is, the assignment operator, whatever value is generated on its right hand side, it takes that value and stores it into the memory. So there is not much difference between what? Scanf and an assignment operator. Both are doing the same thing. Both are storing values. The difference is, this is doing it from the keyboard and this is doing it from the memory itself. Whatever value is there, it is taking the right hand side value. That means what I'll do is, I'll give the assignment operator like this. The right hand side value is generated. Okay, we have to store it in C. So I'll give it what? C. Now what does the assignment operator do? Whatever result is generated here, it takes that value and stores it into what? C. That's the job of what? Assignment operator. That's what the assignment operator is going to do. Are we clear? Okay. So from next time onwards, if somebody asks you why you are using an assignment operator, can you explain them or not? Or I'm just using it because it's a mathematics, I have seen it in mathematics. No. You're not just using it because you've seen this in the mathematics. You're using it because it is required, because you have to take the sum or the processed value and store it into what? Into memory. Once you have given this, now what the computer does is, once it comes here, it adds these two values and stores it into, it adds these two values and stores it into what? Okay, now what is this plus doing? I think you know, right? Or the plus has been given because it's given in mathematics. No. And is this job done or not?
It is done.
Then what I have to do?
Semicolon.
I have to put what? Semicolon. Okay, now is this done? The computer has done its work? No. The computer has done 50%, we can say. Because the first and the most major thing is the result has to be shown to whom? To the user. If the user doesn't see the result, right, then there is no use in writing this. Because you're doing this for the user only. You're writing all these things. Who is the God here? The user for us. Are we clear? So the memory, the value is there in the memory. Now the next job that we have to do is take this value and show it to what? User. The user can view everything on the monitor. That's our next job. Next what we'll do is, we'll take this result, okay, and we have to display it on the monitor. Now from next time onwards, whenever you want to take any value from the memory and display it where? Onto the monitor. Okay, they have given in C language a function which is called as Printf. Okay, what they have given? Printf. If somebody asks you now, what does this Printf do? What it does?
Takes the value from the memory and
displays on
to the monitor. Okay, the structure of Printf is like this. Because the work is done, I have put the semicolon. The structure is like this. Double quotes, comma, and okay. Now which value it has to display? 30. And the 30 value is where?
C.
So you have to inform that what? To the printf. So what I'll do is I'll give C. Are we clear with this? Once you have given C, then what printf will do is it will go to this C variable, it will take that value and it will display it here. But the problem is display where? Right? It will display it here, where in the monitor? That's a problem. Okay, the answer is very simple. Because the computer also knows it directly. We don't have to worry about it. It always displays wherever the cursor is there. Okay? Okay, so that instruction you don't have to give to what? To the computer, because the computer knows that any value that is given, I have to display where? Wherever the cursor is. So if somebody asks you the question where it will be displayed, your answer will be wherever the cursor is. You go and find where the cursor is. Why you are asking me? Okay, so there it will, the value will be displayed. So the printf doesn't have that tension. You know, it doesn't have to see, oh, where I have to display, because it's by default the computer knows that anything you give, I have to display it on the cursor. Right? Then what I'll do is I'll give the format specifier. Okay? Right? Now this is the format specifier and this is what?
format.
Now if I ask you both are same, absolutely no. They look same, but they are not the same. This is totally different. Its concept is totally different, which I can't explain to you right now. In about another 20 or 30 minutes class, we'll understand why I am giving this. Okay, because remember, in programming, I'm again repeating it. In programming, if you have to write a program, you have to know each and everything that you give. You cannot write anything because it's just, if you're writing it, there is a reason. Remember, if I'm giving these brackets and everything, there is a reason, but that reason I'll teach you in the concept which is called as functions, which is very far away from this course. But when we come there, when we learn that concept, then you'll definitely understand why I have given this. Clear? Now we have learned the concept, why you're using it. Okay? So this also we'll learn, but just we have to wait a little bit. We are not going to compromise on anything. Clear about it? Right? So I'm just giving this format specifier. I'll again explain you why I'm giving this. Now once this is done, what the computer will do is take the value, wherever the cursor is, it displays the value to whom?
User.
to the user. Are we clear? Now what you have done?
Added two numbers.
You've written a program, right? Okay, now to write this program, have I googled anything? No. Okay, have I remembered this program? Do I have to remember this program? No. That's how we will learn programming. We will not remember anything. I don't remember even one program. I've written thousands and thousands of programs. I don't remember even one program. I've written even 10,000 lines of code. But I don't remember anything because we don't have to remember anything. What you have to remember is you have to remember the concepts. Once you remember these concepts, automatically what you will do is you will start writing programming on your own without any problem. But this program has a number of problems. Is anybody going to use this program if you ask me? No. They will hate to use this program. There are a number of problems here. We'll try to understand what are the problems here in this program. Remember, there are a number of problems. Now whether you can see it or not, let's see. But there are a number of problems and we'll solve one by one problem so that it becomes a good program. Whenever we write a program, it has to be good so that the computer does it efficiently. So we'll try to learn that part. Okay? Right. So in order to make it a good program, what you have to do is you guys have to learn to execute this program by your own hand. Okay? I think many of this is a big thing that is going on in the market, that you have to execute the program in the computer. No. You don't have to execute the program in what? In the computer. You can execute a program with your own hands and get the result. That's how you're going to learn programming. Okay, that is there. We'll do that also. But this is what you guys have to do in order to learn this programming. Okay? So we'll try to do that. We'll try to execute this program. So the first thing, where to start the execution? We'll start it from here. We'll start it from here. At least you guys know where to start, right? Yeah, right? We know that it has to start here. But the question is, does the computer know it has to start from there? No. Then how will it start executing from there? Have you told the computer that the program has to start execution from there? No. So should we tell the computer or not? Yes. We have to tell the computer that you start execution from here, because we know that it has to be executed from here. Who doesn't know? The computer doesn't know. In order to tell the computer from now onwards, okay, till your computer career is over, you have to always specify to the computer that the program should start from here. In order to do so, what they have given in C language is something which is called as main. Obviously the name itself is there. What? Main. So they are saying this is the main thing. Main function. They call it as what? Main function. And after the main they have given what? A bracket. A curly bracket open. Okay? From next time onwards, whenever you give this, why are you giving this?
To tell the computer where the
Program starts.
starts.
To tell the computer, okay, from where the computer has to start executing this program. Remember, we got to execute this now. Once the computer sees main and a bracket here, it understands that now it has to start here. If I write it here, it will start from here. If I write it here, it will start from there. So now we have told the computer. So one problem is solved. Now the computer knows, okay, the program has to start here. Then it comes here. It sees int. Now it understands, okay, this guy is talking about an integer. And he has given a name. So this is the variable. So I have to allocate memory. It takes any memory location, A. Does it care about any address or not? No. Right? It just allocates memory wherever memory is available. If memory is not available, it will not work. Okay? Right? Next. Int C. You have given int and one semicolon is there. It understands that. Done. I have to move to the next thing. It comes here. We have given what? Int. Okay? So once it sees int, integer, C, memory is allocated. Then int B, memory is allocated. But these guys, what they did is, the C language guys, they've seen that I'm repeating this int always. They felt that if there are 10 variables, how many times I'm going to repeat? Okay, so they found a solution for it. We are trying to find solutions, right, to make this better. So they found a solution. Next time what they say is, the action is the same, but you don't have to repeat what? A. Instead of that, what you can do is, I can use what? A comma. Now why do I use a comma? A comma is used to separate things. Okay? If two people are sitting together in C language and you have to separate them, what you will do? Put a comma. They'll get separated. Have you ever seen a comma in C language? Yes, you have seen. You haven't asked me about it, but you have seen. Now if I show you this, okay, right? Why am I using a comma here?
To separate.
To separate. Because this is telling that here you have to put, and this is checking. So both are different. Now because both are different, I have to do what? Separate them. So that's why I have given comma. Now you understand why I have given comma here? Here comma and here comma. So I can give C also. I don't have to repeat int. No, does the action change or it's the same?
It's the same.
It's the same. The action doesn't change. It's the same. You're telling integer or for what? A, B, C. Now you're asking to allocate what? A, B, C. If I remove this, then
Only
error. Okay, it's not going to work because space is there and variable name doesn't have space or anything. So that's wrong. I'll give a comma. Now 3 memory variables. Okay, so what you'll do is you'll instantly allocate memory here. Remember, we are executing the program by hand, right? Okay, so that is done. Now the user is going to give the value. Okay, here the user is going to look at what? Monitor. Right? So the user is sitting in front of the monitor, he has the keyboard, now he gives 10 value. So this is the monitor that the user is viewing. Okay, we have allocated the memory from the first step. Now the user is sitting. He's looking at what?
Monitor.
Monitor. So the user is looking at the monitor. Okay, what is our programming doing? What is Scanf doing?
Taking the input.
No, Scanf is waiting for the user. So Scanf is waiting for the user to enter value. And what is the user doing? The user is looking at the monitor. So user is looking at the monitor, Scanf is waiting. And what we guys are doing? We are also waiting. So we are waiting, user is waiting, Scanf is waiting. So everybody is waiting. And your program doesn't work. How it will work? Because the user can see a blank screen. So there is a big problem in your program. Right? The big problem is your program is not getting executed. And the problem why your program is not getting, and if your program is not getting executed, this is not a program at all. So if your program has to get executed, the problem you have to solve is your program should start communicating with whom? With the user. That's the problem here. Your program is not talking to whom? To the user. Right? So that problem is there. Now what we have to learn is, we have to learn to talk to whom? Communicate with whom? With the user. So in order to communicate with the user, I'll show you this example. What I'll do is, I'll ask the user on the monitor, enter a value. Okay? The cursor now blinks here. Now if I show to the user, enter a value. Okay, now will the user enter a value or not? It will. Now I am able to communicate with whom? Yes. With the user. Once the user gives the value, then Scanf gets activated, right? Yes. Okay, so what we have to do is, on the monitor, I have to print a text, enter a value. In order to do so, I'm going to use something which is called as which function? Printf function. Now I'll ask you, okay, is this printf and is this printf the same?
No.
No. They look the same, but they are completely different. Can you explain why these two are completely different? Okay. See, in my explanation, I'm asking you a lot of questions, right? Questions. I'm not expecting any answers. Whenever I ask a question, what I'm expecting is you take that question into your head and frame it and keep it there. Once I give the answer, then you're easily able to understand what the answer is if you have that question in your mind. Okay, because you have to get this doubt, right? You're looking at printf, here also printf, both are same, and I am saying that both are different. And yes, they are different because their actions are different. This printf you're using so that you can communicate with whom?
User.
With the user. This printf you're using so that you can take a value from memory and display it where? Onto the monitor. That's the difference. They look the same, but they are different. Clear? So again I'm asking you, why am I using this printf?
To communicate with the user.
To communicate with the user. Now again I ask you, shall we communicate with the user or not?
Yes.
We have to communicate with the user. Wherever you get a doubt in this concept, go back, listen to the class, come back again. That's the best way, because remembering everything is very difficult. Go back, listen to it, come back, and again you can watch it. Okay? So what I'll do is I'll use the structure. The structure is like this. This is different from what?
Printf.
This printf. Printf double quotes and I've given. Okay, now whatever text you want, whatever you want. Okay, you can write it here. So I'll write it enter a value. Once I write enter a value, here it will get displayed as enter a value. So if I remove enter value, then enter value. If I give a dash here, then
Enter.
okay, as it is. So it's not thinking here. Who's not thinking? Printf is not thinking what is there in between it. It's something that you are giving as a programmer to communicate with the user. It's none of, Printf's business. What you are giving in it, right? It's your responsibility how you want to communicate with the user. The more clarity you will give, the more better your program will be. So we are giving a good clear message that enter a value. Once you have given this message, now tell me, will the user enter the value or not? He will enter the value. He has given 50. Okay, once 50 is given, who's going to get activated? Scanf. Scanf will catch the value from the keyboard. It will take that value 50 here. It will check the format %d, where it has to put a integer, %d integer. The format is the same. Okay, once the format is the same, it will take that value and store it into
Memory.
So that 50 value will come here. Okay. Next, so 50 is given and that value is stored here. Next, what we have to do?
Enter the second value.
Okay, again the same situation. So again we have to communicate with the
User.
So in order to communicate with the user, I can write here
Printf.
Okay, put the structure, enter second value. Right? So here you will get what? Enter second value. Now the user is going to enter the second value. Let's say is given 60. Okay. Once is given 60, who's going to get activated? Scanf. Scanf will take that 60 value, put it here, compare this. Okay. Format is okay. It will put it where? Let's say 60. So now in memory we have 50 and 60. So this job is done. So we have executed it and the value is here. Now this will get executed. It will add both these values here. 50 and 60 is 110. What will the assignment operator do?
It will add and put it in.
It will take this value, whatever value this is, it will take that and
Put it in C.
put it into the memory. That's the job of assignment operator. Okay, don't worry. If you have forgotten any concept, it doesn't matter. You can go back, listen to it again and come back. Okay, right? If we have forgotten about assignment operator or anything, so it takes this value, whatever is added, and it stores it into what? C, which is there in the memory. So now the value is stored here. Okay, now once the value is stored here in C, now we have to take that value and display it where?
Monitor.
Onto the monitor. Right? And who's going to do that?
Printf.
Printf. So printf is going to take the C value and it is going to display. You can increase the interaction, that we will see when we will just try to execute it at a later time. Okay, we can improve it a little bit more for the user. Then we'll also understand why we are giving this. Now once the output is done, okay, is your program complete or not?
Yes.
Yes, because the user now can see the result. Now once your program is complete, now your program is completed, you have to inform to the computer. How you will inform it? We'll close the bracket. Once this bracket is seen by the computer, now the computer understands that, okay, done, my job is done. The result is there. The user is happy, the program is completed. Okay, now have we understood everything in here or not? Every part, everything. We have given why you are giving main. Yes. Why you are giving int, why you have given A, B, C, semicolon, the commas, why you are using printf. Any question, don't worry, any question that comes and you cannot answer it, go back, listen to it, come back. Are we clear? So what we have done now, what we have learned? Have we learned the program to add two numbers? Have we learned that? No. You have not learned to write a program to add two numbers. Remove that concept from your head. Okay, what we have learned is we have learned the concept. Okay, where we have learned in a way by using C language, obviously, that the computer will start doing work. It has added two numbers for you guys. You have learned that skill, and that skill is a very big skill. Till now we cannot do anything with the computer. Now what we can do is, computer will listen to us. Right? That skill we have learned today. What we have done is, we have executed this program manually and we have seen the output of it. So that part we have learned. Okay? The next thing what we will learn is, once we have executed this with our own hands, then we will deliver this program to the user. Because we have written down this program for the user. It's not for us. Okay? So how to deliver this program to the user? Right? In order to deliver this, what we do is we have to go to the system. On the system we have to execute this, and we have to follow some steps. Then you will have something in your hand which you will deliver to the. That's the whole concept that next we are going to learn. Clear? Okay. So the question is, what many students forget is, once they go onto the system, what they do is they start executing the program as if it is for them, and they start looking at the output, and they start executing the program looking at the output, okay, and they think that the system is provided so that you can execute the program. But that's not the case. The system is there so that you can deliver this program to the user. Not because the programmer can execute this program, because we have already learned that this program can be executed by us on the board itself. So we don't need the system to execute this program. Then why we have to go to the system? Not to execute this program, but to deliver this program to the user. So it's a two-part story, so we'll learn it step by step. So before learning that, what we will do is, we'll again just look at printf and scanf functions. Obviously, I told you that these two are functions. I'll teach you completely about functions in another concept. Right? And both of them have some work to do. Right? What scanf does is, it takes a value from the keyboard and then it puts it into memory based on the directions that we have given. Similarly, printf also does that. So these all things that I have said, that these two, scanf and printf, are doing. What C language people did is, all the instructions of scanf and all the instructions of printf, right, they are not written here. So what they did is, they have written all these instructions in a file. Okay, and they named that file as a header file. What is the file? The header file. Okay, and they have given the header file name for this as stdio.h. Now the instructions of printf and scanf both are present in what? stdio.h, which is standard input output header file. Okay, these things, the instructions, are not present in this program. So what we have to do is, we have to include this file with our program. then only computer will understand that once scanf, it sees once the scanf function, it understands that it goes here, it understands that how it can take a value from the keyboard, how it can put it in memory. These all instructions are written in this. That is why in C language what they said is, you include this file with your program. So to include this file, they have given hash include. So once the computer looks at hash, it understands that you're asking to include, right, whatever header file instructions are there with your program. So I'll put now this is the structure of it. Hash include less than greater than symbol. I have written stdio.h, which is nothing but standard input and output. STD for standard input and output header file. Now if somebody asks why are you using this or why are you giving this, it's very easy to explain to them that the instructions of Scanf, we know what are those instructions, and Printf are written in which file? stdio.h. And the lucky thing about this is, in the future once we talk about functions, then we will also learn how to create header files of our own. Now this is given by them. C language has given this stdio.h. Now what we will also learn is how we will create our own header files, how we will include this. This we will learn once we have learned the functions concept. Okay, so this part is clear for us. So we have given this, and now we have to deliver this program to the user. So in order to deliver this program, you have to execute this program in the system. Now there are two ways. One, you can do it offline, and the other one is online. Both will learn on the system. Once we go onto the system, we'll learn both the process. But before doing that, what we will do is, we'll just learn the implementation here, how it is done. Okay, the concept is what? Delivering our program to whom? To the user. Okay, that's the concept. So to do that, I have to execute where? In the system. The problem is the system that is there. Okay, if you look at the system, we can call it as the computer or the system. Okay, a computer or the system is nothing but an electronic device. And once you look at it in an electronic device, what do we have in an electronic device? Like a computer.
Keyboard.
If we look at a computer, okay, it's an electronic device, obviously. And what do we have in an electronic device? Very easy. What you have to do is switch on the computer system, open the CPU, and put your hand inside it. What you will feel? You will feel a big shock. So what do you have in the computer system? You have electricity. If you look at the computer system carefully, all you have is some hardware items, and all these hardware items are connected with electricity. No electricity, no computer. So what does a computer have? Electricity. I put my hand inside it, I'll get a shock. There is nothing there. But if you look at that computer, it is performing operations, it is doing whatever we want. But if we think properly, it's only electricity. How it is possible? Right? How the computer is able to add numbers, it is able to do all the things, how it is possible? So what they did is, okay, they understood that electricity, and based on that electricity, they learned to make that computer do operations. Very easy technique they used. Okay, now that easy technique, what they did is they created something which is called as machine language. They created a language called as machine language. And this machine language, they have completely written in zeros and ones. Now we want to learn in depth of it. We have to learn a concept which is called as computer architecture, where all the circuits will be given, how zeros and ones are converted into electricity or electrons and protons. Every explanation is given there. So that is not our concept right now. Our concept is we have to deliver a program to the, but we have to have a little bit of knowledge, at least that your C language, if I give it to the computer, it's difficult for me to deliver it to the user, because the computer is completely, it has electricity, right? And that electricity, due to that electricity, what they did is everything, if we have to implement anything, they have created a language which is called as machine language, and this machine language is written in binary zeros and ones. Now why sir only zeros and ones? Why not some A, B, C, D or whatever? Very simple, because electricity has only two things, protons and electrons. So inside, if I have to do something, I have only two things, protons and electrons. So I need only two values. Protons positive, electrons negative. So I need two values. This is for proton and this is for electron. This is clear. From next time onwards, whenever you write a C language, it cannot be directly implemented because it has to be converted into machine language. They have given something which is called as the C compiler. It's the job of C compiler to convert this. So what we will first do is, we'll take this program and type it in our system. Okay, so we'll type it in a file, and I have named the file as add. Now this add file consists of which program? Our C language program, but it doesn't indicate that. So in order to indicate that that file consists of our C language program, they have given an extension .c. So once they have given add.c, now it is clear that that file consists of which program? C language program. Now this C language program, what we will do is, we'll implement the C compiler on this. Once we compile it, automatically all this, whatever C language, will be converted into machine language and will be put in another file whose name will be add only. But these two are different. This is your C language and this is your machine language. And this machine language, they have given an extension called as .obj, and this file is called as the object file. Now if somebody asks you, what is this object file? It is nothing but your machine language converted, your C language which has been converted into machine language. So we got the machine language. Now this can be executed where? In the system. But there is only one small problem. The problem is the stdio.h file, instructions that are there, these are not included in this because you only compiled your program and you are not included this here. But this object, if you want to execute completely, these instructions must be included with this. So for doing that, they have given something called a C linker. Okay. Now C linker's job is to link your machine language code with the machine language code of stdio.h. It will combine them together. It will not compile or do anything. It will just combine them. So once it combines them and it puts it in a file called as add. Okay. And the extension to this, it will give it as exe, which is nothing but called as executable file. So now we have got the executable file. That means this program is now executable by the system. Once you have this executable file in your hand, this executable file will deliver it to the user. We will give the user this executable file. We'll tell him just double click on it, on this file, and you can add two numbers. So this is the file that we have to deliver. These are all for us. We will never show to the user. We will do this implementation, and very easy. To do this is very easy. We don't have to go through this pain. This is just for our understanding. Okay. So we need to compile it, yes. We need to link it, yes. But everything is done actually very easily and automatically, which we'll look at in the system how it is done. Okay. So now we have the executable file in our hand. We'll deliver it to the user, and how the user will execute it, we'll go on to the system and we'll look at it. Okay.
Next we learn to execute the program online. To execute this C program online, obviously we need the C compiler. So we'll get the C compiler online, and here you'll find a number of C compilers which are available online. So I'll first use the online C compiler from Programmers. The Programmers editor will open. It has two parts. One part is where we can type the program. The other one is the output screen. So we don't need this program, obviously we'll type our program, and here already they have given stdio.h, which is the header file, standard input output header file. Then we will type the program that we have learned, int a b c. We'll give the interaction also. So printf enter a value, scanf %d address of a, and then printf enter another value, and scanf %d address of b. This is equal to a plus b, and we'll give printf %d and c. Okay, so you can, whatever program that we have developed, we'll type it here, and then you can simply click on run. So it will ask enter a value, where we'll enter a value, and I'll enter another value, and the output is given. Okay, so here the output is 35. So we can improve the look and feel of the output. So to improve the look and feel of the output, what I'll do is I'll give result, just to increase the interaction here. So I have given result and %d, and I'll click run, enter value. So now the result is 24. Okay, just to, I have improved this the output of this. Obviously, as we have discussed, now this %d of format specifier is of scanf is different from the format specifier that is declared here, %d in printf. To know exactly why we use %d, what I'll do is I'll just again run the program, and let us enter the values again. I'll give 10 and 20, and if you see, the 30 result is not here, but if you see here the result 30, the 30 value is being displayed between RE and SULT, because the %d location is between RE and SULT. This indicates that this %d is actually used to indicate to the computer where to display the value of C. So this actually gives the location where you have to display the value. So if I remove it here, and if I again give after result %d where it should be, and if I give result 10 and oops, I've got result 30. Okay, so this indicates the location where we have to display value. Now if I have to improve it more, I'll give, we can improve it as much as possible so that we can interact with the user perfectly. So I have given sum of %d and %d colon %d, and I'll give a, b and c. So this %d will represent the value of a variable, this %d will represent the value of b variable, and this %d will represent the value of c variable. So if we run this again, enter value, let me give it as 13. So sum of 12 and 13 is 25. Okay, so this is how we are going to execute programs online, so that we can if there are any typing errors while we have written down any program, that can be solved easily, and the program can be developed here. The next part is to obviously generate the executable file so that the user can use it. That we will learn in the next session of system execution. So next what we'll do is we'll generate the executable file by using two options. One will use the Turbo C compiler, and the other will use the GCC compiler. So first we'll look at Turbo C compiler. So to download the Turbo C compiler, you have to type Turbo C++ compiler download. Here you'll have the download option. You have to download the Turbo C++. Click on this, then a zip file will be downloaded as per the instructions. Then you have to run the setup.executable file. So I have already downloaded it. Here's the zip file. Once I extract it, I'll get this turbo C2, and as instructed, here you have the setup file. You double click it, obviously all the setup process will take place because already I have installed it. So once I double click on it, it will just check the pre-installation and it will give an information that it's already there. Okay, but for you it will install it. Now once the Turbo C software is installed or the compiler is installed, you'll get a folder in C drive, Turbo C3 folder, where all the installation files are there. So these are the installation files. Next we have to open the editor of the Turbo C compiler. To open the editor of the Turbo C compiler, in the start menu you have the Turbo C++ option. So I'll click on the Turbo C++ option and I'll click on Start Turbo C++. Now this is your C and C++ editor. Actually this looks like a C++ editor, but it you can develop the C programs here also. Once we have done that, what we'll do is we'll take a new file. Okay, once I've taken the new file, then we'll type the program that we have, #include stdio.h. So this is the program. So I've typed the entire program now. Now once we have typed this program, then we have to save it. Obviously to save it, you can go to File and click on Save As. Remember, we need a C file, so we'll say add to numbers.c. This will give us our C file. I'm storing the C file in C drive Turbo C3 bin folder, so I'll click on OK. Now my add to numbers program has been saved. Now once we have saved this, then we have to compile it. So to compile it, we'll go to compile and we have to click on Alt F9. Okay, so my program has been compiled. If you see here the errors are 0, there is warnings. We can just ignore the warnings at this point of time, no problem with that. And the lines compiled, if you see, it's 318, but actually you have written the code of what, 6 or 7 lines, but it is showing 318. Now this 318, the other 310 lines of code is from the stdio.h header file, which are the instructions for printf and scanf. So these numbers are coming from there. Okay, so this is done. Once you have compiled the program, the next part is we can run the program. To run, obviously we have to use the run option, or you can press Ctrl F9. So I'll press Ctrl F9. Now once I click on Ctrl F9, now I have what you're viewing is the user screen. So this is what the user will see. But if you see, the user is saying C Turbo C 3 bin TC, which is not correct. The user should see only enter a value. So there is a problem with your program. But we can enter values here. Let me enter 10, let me enter 20, and when I enter it, then I have to get the output. Okay, once I hit the enter button, I haven't got the output. So to see the output, what you can do is you can go to Window and there is an option called as user screen. As I said, that is the user screen, and Alt F5. So if I click on user screen, and if you see the output now, it is 30. Okay, but still that shouldn't be the case. Once the user enters the second value, he has to see the output directly, rather than we have to go to Alt 5 and hit user screen. So there are two problems that I can see in this program right now. One is the user, whenever we are opening the output screen or the user screen, okay, he's able to see the if I select Alt F5, he's able to see all this older Turbo C3 and all. So in order to solve this problem, what we'll do is, whenever before displaying the enter value, what I'll do is I'll use a function called as clear screen. So once we use clear screen, what will happen is the instructions of clear screen will be included in a header file called as conio.h. Now the purpose of clear screen is to clear the screen before we display the enter value text. So let us just run it again. Okay, now if you see, we don't have the Turbo C3 or any other text here in the user screen. We have only enter value. Now the user can enter value, but still we cannot see the output. So if you have to see the output, we can go to Alt 5 and here is the output 30. Okay, so I think it's clear that why we are using clear screen. Clear screen is to clear the user screen before going there, before printing the or displaying the enter value text. So that is why we are using clear screen, and the instructions of clear screen are in the header file called as console input output header file. From a programming terminology, the user screen is called as a console. So they have given it as CON represents console input output header file, and the clear screen instructions are here. If I compile it, if you see here, before we got 318 lines when we compiled the program, same program. Now we have 467 lines compiled. So this 467 lines are the lines that coding lines for conio.h header file. So all the instructions for clear screen are given in this, and those are showing up here, the additional lines compiled. Okay, so that is your clear screen. Now there is still one problem with this program. If you can see, I'll hit Control F9. Let's enter a value. Let's enter another value. I'm not able to see the output, and I have to click Alt F5 to see the output. But the user, we cannot tell the user to click Alt F5 to see the output. So what we will do is, after displaying the value, okay, once we have displayed the value, what I will do is I will give a function which is called as getch. Now getch function will completely learn in strings concept, why we use getch concept, but currently getch, what it will do is it will take you back to the user screen once this is executed. Okay, so if I run now, enter value 10, enter value 20, and now you see we directly see the output, because getch, what it did is it has, instead of we pressing Alt F5, we have directly come to the console, which is the output screen for the user. Okay, so that is why we are using getch. The instructions of getch is included in the conio.h file. So the instructions of clear screen and getch both are in the console input output header file. Now as we discussed, we can display the output much more sufficiently. Sum of %d and %d is equal to which is the right way to go. We want the output to be as clear as possible. So I'll run this program again. We'll enter the value and you get the output. Sum of 10 and 20 is equal to 30. Okay, as per the class that we have learned, the main target for us is to deliver the program to the user. Right, to deliver this program, we cannot ask the user to come here, run the program in Turbo C, or that's not the solution. So what we have to do is we have to deliver the user the executable file. So let us see where the executable file is. So remember, we have shown the Turbo C3 folder which has been created when we installed the software. In this Turbo C3 folder, if you go to the bin folder, if you see here is your add to numbers C source file. Okay, if I open this, let's say I open this with my notepad ++, here's the C program that we have created. So this is the add to numbers .c program that we have created. Okay, And once we compile it, in the source folder you have two files. One is the application file and the other one is the object file. Obviously, as we discussed, the object file is nothing but it has only 1 KB. That means it's the compiled code of your program. Okay, now this is the machine language. Now if I open this in my Notepad+, this is machine language, garbled machine language. Okay, and if you see the extension, it is .object file. So whenever you compile the C program, what will happen is it will generate an object file which will consist of the machine language, but this machine language will include only your program. It will not include the stdio.h or conio.h. But we need the stdio.h and conio.h instructions also. So if you go back to your folder, here is the executable file. Now if I open this executable file, let's say, now this is your complete machine language that has been created, and if you see, this is the executable file, and this executable file will be delivered to the user. Clear? So once you compile your program, object file will be created and your executable file will be created. You can deliver this executable file to the user, he can execute it and he can see the output. So we are clear about this. Okay. Right, now what I'll do is, now this is how you normally use Turbo C editor and compiler. Normally what I do is I also use the GCC compiler, which is much easier for me. So I'll show you the GCC compiler implementation also, how to use GCC compiler. So let's go for the first step regarding the GCC compiler. So we'll go to Google. Okay, and we can type GCC compiler download. Okay, you have the sourceforge.net website. So here what you can do is click on this and click on download. Once you download this, you will have your GCC compiler downloaded. Okay, and this is the GCC compiler that has been downloaded. If you see in my desktop, it is 45 MB, so it will quickly download, and this is the GCC compiler. In order to install it, it's very easy. It's the same as the other installations. We can double click on it. You will have the create option. Click on the create option and click next, and automatically it will get installed. Now this is already installed in my system, the GCC compiler. This is how we are going to install the GCC compiler. If I click right create, then it will obviously say that it's already installed. So I don't need to install it again, but you can just click create, click next, and it will be installed. So once I have installed the GCC compiler, so just copy the program from online that you have created and copy it into a new file and save it in some folder. So what I'll do is I'll save it. Let us say, let me go to file and click on save as, and I'll give it as add to numbers.c. Okay, I'll save it in my C drive and I'll click save. So now if you see, I've saved the file in my C drive. Okay, so if I go to my C programs, I have the add to numbers program which I have saved here. The next thing what I'll do is you can go to the start menu, and here you will find the min-gw command prompt of the GCC compiler. Okay, so this is the min-gw command prompt console. Now once you have come here, we actually have saved the program in eDrive C programs. So let me go to eDrive, eDrive CD C programs. Now the command is gcc. You will give your file name add to numbers.c. -o is the command for the output file, and you can give any name that you want. I'll give just add to num to make it different. Now once I've done that, right, you will see that there is a warning which I said that we can avoid at this point of time, because we can deliver the program even with this warning. We'll obviously learn this and we'll avoid it next time. So what has happened now is that your program is compiled and the executable file has been generated. If you see here, this is the executable file that we have generated. That's it. So the work of GCC compiler is completed and your executable file has been generated here. If you double click on this, now this is the user screen and it's asking for enter a value. You can enter a value here and now you got the output. Okay, so the C program that you have developed. Let me repeat it again. Once you want to deliver your C program, go online. This is my procedure. I normally use it. Go online, type the program there, remove any typing errors, see the output there. If everything is working, then copy that program on some editor. Use Notepad plus whatever editor you want. Type it there, save it as a .c file. Once you save it as a .c file, then you go open your C compiler, GCC compiler, and execute the command as I've shown you, and the executable file is created. Now what I can do is I can deliver this executable file to the user. So I'll give this to the user. Once I give this to the user, whenever the user wants to use or add to numbers, he can just double click on it, enter his values, and he will get the output. Next, these are some of your sample programs or practice programs that I am giving to you based on what we have till now studied. So these are the sample programs that you need to develop now. Now these are very easy programs. If you look at all these programs, very simple programs. The main target of you developing these programs is so that you learn the procedure of how to develop these programs on your own. I don't want you to go to Google, type subtract two numbers program and get that program and look at the output, or any of these programs shouldn't be done like that. What you have to try to do is learn the procedure of how to develop these programs. Already I have shown you how to add two numbers programs, right? Now you can go back, look at that program, how I developed it. I first found out whether I can subtract two numbers or not. Yes, if I can subtract two numbers, then I went to the system and I've seen that whether the system can subtract two numbers, in which way the system will subtract two numbers. Once that is done, then I implemented one concept after the other to write the program on my own. The target of this exercise is totally to see that you guys can develop or learn the procedure to develop this program on your own, but the target is not to get the output of these programs, because I can assure you these are the most simplest of programs you can ever find. So what I'll do is in the next class I'll take one or two programs out of this and I'll show you how I will write these programs. I will show you the procedure, step-by-step procedure, how I'll develop these programs on my own. I'll show you one or two programs. You look at them. Once you have seen them, then you take a pen, paper, and based on it you write each and every sample program here. Because I'm telling you, if you come up and successfully show me all the outputs, I will not be happy. I'll be happy if you tell me that you have learned the procedure to write a program on your own. And if anybody gives any such kind of program, you can confidently say that you can develop the program. Then only we have successfully learned whatever in this class, in the first class that we have learned. Am I clear?
So I've given you a list of programs. Now what you have to do is take this list of programs, develop it on your own. Don't copy it from Google, don't take it from anywhere, right? But develop it on your own, where take a paper, take a pencil, start developing it on the paper book and see that you are able to develop that program on your own. That's the whole concept here. Okay, so what I will do is I'll take one or two examples out of it. I will show how I will do it. Okay, you can follow me for the rest of the programs. Check them out whether you are able to follow the process that I am able to. So we are concentrating on the process, how I am developing the program. I don't remember these programs. The problem is I never remember any program, no matter 10,000, 20,000 lines. I don't try to recall what is. I only try to remember the concepts. So when you're developing this program, in your head only the concept should run. What is data type? What is Scanf? Where I have to use this? How can I deliver it to the user? How the value is passing from the memory? How I'll get it from the memory? How I'll display? So these are the concepts that you are learning. So when you're writing the program also, you have to keep in your mind that you are running with those concepts. So I will try to explain how I will develop this program. We'll take 2 examples and we'll try to explain both the examples here. So we'll start with, what I'll do is, in the list I have given you that we'll find the remainder of 2 numbers. Okay, so now we have to deliver that the user should be able to find, whenever he gives 2 numbers, he has to find the remainder. As I've already told you, if you have to develop a program on your own, the first thing you have to know is, you have to know yourself how to find the remainder. Now if you don't know to find the remainder, then we cannot write the program, or find out and then you implement it the way I am doing it. So all the programs that I have given in the list are the same. You don't know anything, don't worry. Find out how it is, what is its formula or whatever it is, and then come back and start doing or developing the program. So I know how to find out the remainder, so I'll try to implement it. Okay, so we'll divide this into like this. Okay, this block is for the user's point of view, and this is my programmer's point of view. Okay, so normally what I do is, remember I have developed number of big softwares, and even if I develop a big software, right, we have created our company a software which is similar to Gmail also, but you will be surprised that even if we are building such a big software, a programmer's point of view is important, a user's point of view also is important. So what we are learning is, we are developing as programmers, thinking like programmers. That is the concept here, not finding or writing a program to find the remainder. Okay, so think like a programmer. So in order to develop softwares also, the process is the same. Amazingly, it is the same. Okay, so what I'll do is, I'll first develop the programmer's point of view. That means how I know to find the remainder of 2 numbers or not. Then we'll come and look at the user's point of view, and then we'll try to develop the program. So 3-step process. Okay, so from my point of view, if you give me 2 numbers, obviously I'll divide them. Let's say I've taken one as 5, 7 and the other one as 5. So the 2 numbers that I've given is, one is 7 and the other one is 5. Now I have to find the remainder. Obviously division is quite simple, so 5 ones are 5, I'll subtract it and I have got 2. Normally if you have learned mathematics or just Google it, you will find it. This is called as the dividend. This is called as the divisor. This is the quotient. And this is the remainder. That's it. So no, I know how to find the remainder. That is confirmed. Now similarly, we look at from the user's point of view. I'm not still writing any program, but I'm looking at the user's point of view. The user, obviously, as I have shown on the system, he'll use your executable file. Okay, so he'll have keyboard in his hand and he'll have the monitor from the user's point of view. So let's go here. So user has the monitor in his hand and he has the keyboard. Okay. Now from his point of view, let us implement this. He's clicked your executable file, let us say. Then what I'll do is, I'll ask him to enter. Obviously, what he has to enter, one value, the dividend. So I'll ask him to enter dividend. The user will now enter dividend 7. Okay. Then I'll ask him to enter the divisor. So I'll say enter divisor. He will enter 5. Then I'll show him the remainder. I'll show him the result. Now this is the user's point of view. This is how the final delivery must be implemented by the user. This is our point of view, we are clear, and this is user's point of view. This is how it has to be implemented. But because we have learned programming, and if you don't recall it, if we have to go back and look at the program that we have learned, right? In order to write the program, we have to see that the computer should work, it should work in such a way that if the value is given from the keyboard, right, we have to take and put it into memory, and we have to implement that entire process, right? So what we will do is we'll now implement that entire process also. So in between this monitor and the keyboard, what we'll do is we'll introduce the memory, which is important. So I'll bring down the memory here, and the memory is divided into blocks. Okay, now the keyboard is here, and the user will start giving values from here. Okay, so now we'll start the entire process again, but now what we are doing is we are writing the program. We have started developing the program, and once we have started developing the program, already we have seen that it's best that I can include what? stdio.h header file. Okay, and I have to tell the computer that start the program from here. In order to do so, I'll give what? Main. Once the computer sees main, it starts executing the program from there. Okay, the first value given by the user is what? 7. Right? So from the keyboard is giving 7, and 7 is what? Dividend. Now what you have to do is, once the user gives this value from the keyboard, I have to put it in what? Memory. But before putting into memory, I have to tell the computer that what value it is, and you know what value it is. It's an integer. Right? Now if it is an integer, I have to inform to whom? To the system. In order to inform to the system in C language, we have learned what? Now once I have given int, now you are informing to the computer that the user, that the whatever value the user is giving, the first value will be an integer. Also we have learned that we have to put that value where? In the memory, but we don't know where to put it, so we have to allocate a memory. And in order to allocate a memory, we have to use a variable. If you have forgotten all these things, don't worry, go back, listen to the program again, listen to the class again carefully, come back and then start again. Okay, we are learning how to develop this program. So now what I'll do is I'll allocate a memory. A memory for what value? 7. Right? So what I'll do is I'll allocate a memory, and I'll give a name to it, and we have learned we can give any kind of name. So let me call it as DVD, dividend. Okay, so in order to do so, int I will give what? DVD. Once I have given DVD, now the memory is allocated. Right? So one job is done for 7. Similarly, the user is giving what? 5. Now 5 value also I have to store here, which is nothing but your divisor. So I'll allocate another memory location, and I'll call it as DSR. Whatever name, I'm giving my name. So divisor, so I've given it as DSR. So comma, and I have given DSR. Now once I have given int, DVD and dividend and divisor, automatically the memory is allocated now. So that part is completed for us. Okay, so we have created the memory. Once the memory is created, now what we can do is, once the value is given by the user from the keyboard, I have to take that value and I have to put it into dividend. Right? In order to take the value from the keyboard and put it into this dividend, what we will use? We'll use Scanf. We'll write the structure of Scanf. We have to put it into what? Dividend. So address of, we will give what? Dividend. And obviously dividend is what? Integer. So I have to specify the format, which is obviously %d. Okay, why I am using format specifier? Go back, listen to it if you have forgotten. Right, so this part is completed. Once this part is completed, the user will give the value and will take that value and it will put it into DVD. But the problem is the interaction. We have to interact with the user. Okay, so before this fellow giving the value, I have to give an interaction. So to give that interaction, we'll give what? printf, and I'll write it as enter dividend. Okay? Once I have given enter dividend, it will come onto the monitor. The user will see, okay, I have to enter dividend. He has entered the value 7 from the keyboard. Scanf will catch that value and put it here. So this is clear for us. Next he will give divisor. So I have to ask him what? Enter the divisor. So let us say we'll ask him printf enter divisor. Okay, now once we have given enter divisor, obviously the user is going to give the value 5. I have to put it here, so we'll use scanf. We'll write down the structure, address of where we have to put it.
Yes.
Okay, and we'll give the format specifier. So now we have the 7 value and we have the 5 value. Now once we have this, now what we have to do is we have to find the remainder. What C language people did is they made this easy for us. What they said is, okay, or what they created is they created an operator itself. Instead of doing this division and doing all these things, they are doing everything and just giving us the result. So what they did is they created an operator which is called as the modulus operator. We have already seen arithmetic operators, plus, minus, divide. Plus was, it used to add, right? Similarly, they have given which operator? Modulus operator. Now if somebody asks you now, in C language, what does modulus operator do? Very easy. It finds the remainder. All you have to do is give the dividend and divisor to it. Once you give dividend and divisor to the modulus operator, it will find the remainder. Okay, so to do that, what they did is in C language, the modulus operator is represented by percentage. But remember, in C language, percentage is completely different. And we don't even spell it as percentage. We call it as mod. So next time onwards, we don't say percentage, we say mod. The modulus operator is mod, which will find the remainder. All you have to do is, okay, you have to specify the dividend and divisor. So now in the program, obviously the dividend is present in DVD. So I'll give DVD and I'll give mod, right? And the divisor is DSR. Okay, the modulus operator, how they have created it, they take the left hand value as the dividend, they take the right hand side value of the operator as divisor, and they divide it and they generate that, means the output will come, they will give the remainder as its output. So that's the job of what? Modulus operator. So this concept we have learned new. That has come out of this program. What? Modulus operator. It finds the remainder of two numbers, the dividend and the divisor. Okay. So once this is done, but this value that is generated, obviously the dividend is 7 and the divisor is 5. So the result is 2. Because the modulus operator, definitely it will calculate 2. And this 2 value must be put in what? Memory. But the problem is we haven't allocated any memory. So now next what we have to do is we'll allocate the memory, and we know. And 2 value is obviously integer, so we have to specify to the computer. So I can give it as what? Int, comma. And what I'll do is I'll allocate the memory. Let us say, let me call it as remainder. See, the variable names also that I'm giving, a little bit I'm giving in such a way so that I can identify. The names also. So you also should give name that you can identify. You can give anything. I can give A, B, C, D, Z, X, Y, Z. But why I'm trying to give something which is identifiable, what kind of value I'm putting in it. Okay, so what I'll do is I'll give REM, remainder. So I know this is dividend, this is divisor, and this is remainder. The more specific it is, the good it is for us to understand. So now the memory has been allocated. Now once the memory has been allocated, the value is also generated here. And we know how to take this value and put it into the memory. In order to do so, we have learned an operator called as assignment operator, which we have already seen in the class, that it is something similar to Scanf, where Scanf also takes value and puts into memory, and assignment operator also takes value and puts into memory. Okay, all it does is it takes the right hand side value and puts it into the left hand side, and where we want it, remainder. So what I'll do is I'll give it as, now the assignment operator will take 2 value and it will put it into remainder. Now the 2 value is here. Okay, so this is done, but this is in memory and we know that user cannot see memory, so we have to display it here, right? So to display it here, what we'll do is, obviously we'll take the value from the memory and put it into the monitor. To do so, we will use Printf and we'll give what? But as we have already learned in the class, why we use this? So what we'll do is we'll be more specific about it, because on the system already we have learned why we are using this. So we'll give it as printf remainder %d and which value? The remainder. So now what has happened is remainder and the value is 2. So the user has got the output. Now this program has given the result. We'll generate an executable file, give to the user. The user will implement always like this. So he'll start giving his whatever values he'll give, he'll get the remainder. Clear? So we have written a program to find the remainder between 2 numbers. And we have written it on our own by not remembering. Now the list that I have given, you have to try to implement this list in this way. If you start developing like this, slowly what will happen is we'll get into this habit, and whatever bigger programs also come, you'll solve it very easily. So this is the process that we are going to implement. Now once this is clear, okay, I'll take another example to teach you another concept. Okay, this is a small example where we have learned about Modulus operator is one thing that is new here. So we have learned this new concept. The next program also will teach you a new concept. So we'll try to learn that also. Okay, right. So what we'll do is, let me cut this off. Okay, let us keep this. We need this. Remove this. ये सब कट कर सकते हैं. Okay. 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 Next, what we'll do is, in the list I have chosen a program called as area of a circle. So we'll try to find the area of a circle. Now if you have to find the area of a circle, obviously it's a mathematical formula that we have to use for the area of a circle. If you Google it, you will get the formula. So I went to the Google. The process is the same, don't forget. Okay, so I went to Google, I found out they have given the formula as area is equal to pi r square. Okay, this is the formula that they have given, right? But to execute this and to implement this, what I'll do is I'll simplify this, because pi we know has a value, pi value. So what I'll do is, well, I'll take an example. Remember, what we have to do is we have to develop an example and we have to get the output. Our job is not to look at the formula or something like that, right? So what I will do is I'll find this. I'll give some value and I'll find the result of it. So to do so, what I'll do is, let's say area we have taken, okay, pi value is taken as normally 3.14 is the pi value, right? Then I have taken radius, okay, let's say I'll take a radius of, to make it easy, we'll take it as 10, okay, because it's r square, it is nothing but 10 into 10. Right? So the radius we have taken here as 10. We'll multiply it, obviously 10 into 10 is 100. So 3.14 into 100, which is nothing but 314, let's say, square meters. So the area of circle is 314 square meters for my example. So this is simply I found out the area of a circle. Now because once I've got the area of a circle, very good, you don't have to do program after or find sum after sum. Okay, now once you have done this, now from a user point of view we have to implement the same thing. So from a user point of view, what I will do is to implement the area of a circle. Obviously I'll ask the user to enter the radius, right? So I'll give enter radius. Remember, when you come from the user point of view, you have to exactly know what the user has to give, what the user is expecting as an output, right? Here I'm expecting the output of what? Area of the circle. And here the user is giving what? The radius. He can give 5, 10, 20 or whatever it is, he can give here, right? So that part you have to know what the user is going to give to your system, that and what output he is expecting. So here he is giving radius and he is expecting the output of the area of circle. So he is given here, let us say 10 as per R. So the radius is given 10 once he is seen here. Okay, instantly we'll give the output area of circle is equal to 314 square meters. This is the output we'll display. Clear up to this part? This is how the program should be executed for the user. This is how we'll do it. Now what we'll do is we'll try to write the program for it. Obviously we have already written this. We'll start the program from here. Clear? Right. Now the user is giving this 10 value. Now once he gives this 10 value, we have to inform the computer what value it is. So I'm expecting an integer. So what I'll do is I'll give an integer. So I'll specify int. Right? Now I have to allocate memory for this value. Okay, in order to allocate memory, we'll use a variable. We can give any variable because we are already using R, which is identifying the radius. If you want to write it completely as radius, very good. It doesn't matter. Okay, so I'll give it as R. So once I give R here, what is allocated? The memory is allocated for R. Okay, so this allocation is done. Now this 10 value can be put into this. We know that, but before that we have to interact with the user and ask him the radius. So I'll give printf enter radius. Okay, now once I've given enter radius, the user will enter the radius 10 value. So I have to take that 10 value, catch it, and put it into R. So I'll give address of what? R. And obviously because it's integer, now Scanf will take that value and put it here. Okay, so this is done. Now the value is here. So once the value is here, now what I have to do is I have to calculate it. And in order to calculate it, I am multiplying 10 with again 10. Okay, and I am multiplying it with 3.14. So what I'll do is I'll take 3.14, I'll multiply R value, and again I'll multiply it with R value. But if you see, I'm doing multiplication, and in multiplication I have to write this in C language, but this is not in C language. Remember, always we have to write it in C language. So to write it in C language, obviously this is the multiplication operator and we'll use the asterisk. Okay, so 3.14 is multiplied with R and it is multiplied with R, right? And the result is how much? 314. This 314 again must be stored where? In memory. But in order to store that into memory, obviously we have to allocate memory for it. What value it is? Area. So let me allocate a memory and let me call it as A, or if you want more clarity, we'll give it as area. Okay, here what we will do is we'll wait a little bit and we'll see the value of this. This is what? 3.14, which is decimal values. That means if I multiply it with 5 or 6 or something, I'll again receive a decimal value. Now this is your decision here. Now because I'm expecting a decimal value here, that means I have to store a decimal value here in the future. And in order because we are storing decimal value in C language, they have given something which is called as what? Float. So now you're telling that in A we are expecting a decimal value, a float value. So I'll give float and I'll give area. Once I give float area, now a memory will be allocated for decimal values and the name will be given as area. So now I have allocated the memory also. Now once the processor calculates this, the processor will multiply because you have asked it to multiply. Once it multiplies it, the result has to be put in what? Area. To put this result into area, we have to use which operator? Assignment operator. The assignment operator will take this 314 value and put it into what? Area. So let me write area here. So the 314 value has come here. So I've got the area. Now once I've got the area, I have to display this area here. And I'll use what? Printf. So as we have learned in the system, we got to get the output like this. So to get this output like this, we'll give area of circle is equal to %d square meters and I'll give area. Automatically, wherever %d is given, it specifies the location where the value has to be displayed. Right? So because I have given %d here, the value of area will be displayed here. If I give this %d here, the value of the area will be displayed here. So this %d is used to specify where the value has to be displayed. Okay? So we have given that, now we have got the output and the program is done. Now this is nothing but a program to find area of a circle. Clear? Now the concept that I was talking about, okay, which we thought that we will learn, right, is very important and it will be useful for future programming. Right? If you look at this value, this is 3.14 value. This has never been given in memory, right? And this is our value, but this we have given it in memory. Clear? Now why this is not required in memory? That value we haven't put it anywhere in memory, right? Now why this is not required in memory or why we don't have to allocate it here is one question that is pending here. Now in C language actually this value is called as a constant. The 3.14 is called as what? Constant. And if you look at C language book, programming book, the definition of variable they have given. The definition of variable they have given is, a variable is that whose value changes. But I have not taught you like that because I am thinking from a programmer's point of view. I don't want to go to these book definitions because book definitions are very confusing. And they will not make you a programmer, right? They'll see that you write an exam and pass the exam. But here we are learning programming. To learn programming, we don't have to go through that concept of textbook definition. But if you see variable, and the definitions are correct, I'm not saying they are wrong, but from a programmer's point of view, we don't want to learn those definitions. Okay, if you look at variable in textbook, they have rightly written that a variable is that whose value changes. Right? A constant is that whose value doesn't change during the program implementation. Okay, now if we look at this variable, right, now the variable value is 10. Now if the user gives 5, then it changes 5. If something else is given, then it will change to that value. Okay, now because its value is changing, what we are doing is we are allocating it into the memory. Now because this value is not changing, we are allocating it to the processor itself. What the processor will do is, it will take the 10 and 10 value and it will directly take the 3.4 value from here. It doesn't have to go to what? The memory, because the value always remains the same. So we don't have to change this or put this into some variable or, no sir, I want to put it. You put it. It is your headache. But you are taking the risk that that value can change. But I cannot take that risk. I don't want that value to change. For example, if somebody comes up, no sir, I want this value in memory. We don't want it, but I want it. Simple. You take another allocate memory. Okay. You put that value there. which is unnecessary, right? And then we can implement it. So show us once how to do it. Let's do it that also. Not a problem. Okay, so what I'll do is I'll take this pi value. Okay, so what I'll do is I'll declare pi value is float, so I'll give it as float. Okay, we'll give it as pi, right? I'll give is equal to, we know it's an assignment operator, 3.14. Okay, now 3.14, I'm putting it in what? Pi. Now pi is obviously a variable. Once I give float pi, memory will be allocated and pi variable is there. Now because I'm using an assignment operator, anything on the right hand side value will go into what? Pi. So now it is 3.14. Right? Now instead of putting here 3.14, I can write it as what? Pi. Pi into r into r. Right? So what I did is I declared a constant value which will not change within a variable. Okay, this what it has done is it has improved the look and feel of the program. That means if some other programmer comes and looks at the program, he clearly understands the formula of the area of the circle, where area is equal to pi into r into r. So this improved the look beauty of the. Now I don't want this. I want to put directly 3.4. You put 3.14. It has no problems. Nobody is going to complain that why you have put this value here. Okay, but for better programming, what we can do is we can declare this also. Put the constant value into a variable. Now there are two concepts that we have learned. In programming, you can look at two things. One is constant value, variable value. Constant value will not change, whereas variable is that whose value will change, will keep on changing. Clear? So that is the concept that has come out of this program. Again, I am repeating, once the list of program you start doing it, first find out the working, get the output with your own hands, then see that the user sees the output in the manner he wants to see, then see what values he is giving, how it is doing, then start writing the program, allocate memory according to his requirement, one by one, take the value, execute in the memory, right? Bring the formula here, whatever working you have done here, implement it and then display the output. Automatically what will happen is you write the program. Once you've developed all these programs, then what you do is you go into the comment section, and I recommend you that whatever doubts you have in these programs, please give it in your comments. If you're struggling with some programs to understand, I will again recreate those and I will explain to you those programs. But you should comfortably, I think, you should be able to develop these programs on your own and concentrate on the procedure how to develop these programs. The journey of this doesn't stop here. We will learn C language, then we learn C++, Java, advanced Java, PHP. I'll also teach you scripting languages, HTML language. I'll also teach you MySQL. So it's a long journey, but the journey will take you, or in this journey, what I will do is I will see that you become a software developer where you can develop projects and deliver to the clients. So I request you to subscribe. Share this video to as many people as you can, and do comment definitely on the list of programs that you see. Thank you for watching. Thank you.